everyone. Today in this video, I would like to explain you about the ionic bond. By taking the electrons in the valence shell, we'll try to write the dot structures for the ionic compounds. First, we'll define what do you mean by an ionic bond. So this ionic bond was first introduced by Kozel. See, the ionic bond, the chemical bond that is formed by the transfer of electrons from one atom to another is known as an ionic bond. So transfer of electrons. So whenever one atom loses the electron, it forms a positive ion called as a cation, and the other atom which gains the electron forms an anion that is called as a negative ion or anion. So the transfer of electrons takes place from one atom to the other atom, which leads to the charged particles. So these charged particles have strong forces of electrostatic attractions, which lead to a bond called as an ionic bond. So the positive ions, that are the cations, and the negative ions, which are called as the anions. These are formed by the transfer of electrons from one atom to the other atom. Generally, the atom which transfers the electron will be a metal, and usually having the electrons 1, 2 or 3 in the outermost shell, and the atom which gains the electrons will be a non-metal, and usually its outermost shell will contain 5, 6 or 7 electrons. So transfer of electron takes place from metal atom to a non-metal atom. So due to this transfer of electrons, it forms the positive as well as the negative ions. So there exists electrostatic forces between the positive and negative ions, which forms a chemical bond. Such a bond is called as an ionic bond. And because you are finding the electrostatic forces between the charged particles, it is also called as electrostatic bond. And because you are taking the valence concept, that is the electrons present in the outermost shell, this concept, valence concept, is explained in terms of the electrons. It is also called as a electrovalent bond. So you can say as an ionic bond or electrovalent bond or electrostatic bond. Now we'll go through some of the examples which have an ionic bond. Now I am taking the first example as a sodium chloride as the first example for the ionic bond formation. NaCl. Sodium chloride is formed from the elements sodium and chlorine. Now we'll write the electronic configuration for sodium and chlorine, and let us see the outermost shell electrons. Sodium, its atomic number is 11 and its electronic configuration is 2, 8, 1. That means in the first shell 2 electrons, second shell 8, and in third shell it is having 1 electron, which is the outermost shell. Sodium, it can donate its 1 electron so that it can have the octet configuration of neon. That means sodium can form a cation. Sodium is a metal. So generally metals whose which has 1, 2 or 3 electrons in their outermost shell can form cation. So sodium in its outermost shell contains 1 electron. So it transfers or it loses its 1 electron to get the octet configuration of neon, and it forms a cation. And now chlorine, if you take, chlorine atomic number is 17 and its electronic configuration will be 2, 8, 7. That means it is short of 1 electron to get the octet configuration of argon. So whenever chlorine, it gains 1 electron. So if it gains, it forms an anion. So chlorine, if it gains one electron, it forms an anion and get the octet configuration of argon. So its valence shell will have the 288 after gaining an electron. And sodium, after losing its electron, it has the configuration as 2, 8. So sodium forms a cation and chlorine forms an anion. Sodium is a metal, so it forms a cation. Chlorine is a non-metal, so it forms an anion. Now we'll see the transfer of electrons for this sodium, that is from sodium to chlorine. Now we'll see the transfer of electrons from sodium to chlorine. Sodium atomic number we have seen as 11 and the configuration as 2, 8, 1. So this is the sodium with 11 protons at its center, and this is the first shell containing 2 electrons. Second shell, it is containing 8 electrons, and in the third shell, this is the third shell, so this contains 1 electron. This is the third shell which is going to lose its electron. So this is sodium, and in chlorine you will see that you have seen that its atomic number is 17 and the configuration as 2, 8, 7. Chlorine will have 17 protons that in its nucleus, and this is the first shell which is containing 2 electrons. Second shell, it is containing 8 electrons, and in the third shell it contains 7 electrons. So it is short of 1 electron. So this sodium will lose its electron which is present in the last shell, and this chlorine which is short of 1 electron will gain 1 electron, and it gets the sodium gets the octet configuration of neon, and chlorine gets the octet configuration of argon. So now let us see the transfer of electron from sodium to the chlorine. So that one will form as a positive ion and the other will form as a negative ion. Sodium will form a positive ion and the chlorine will form a negative ion. See the transfer of electron. So this is the transfer of electron from sodium to chlorine. So now we are seeing that sodium will form a positive ion and then chlorine will form a negative ion. So after transfer of electrons, sodium becomes as Na plus with configuration 2, 8, and chlorine, after gaining 1 electron, it forms Cl minus with electronic configuration 2, 8, 8. Okay, now we'll represent in the form of a Lewis dot structure for sodium chloride. Formation of sodium chloride from its ions. We have seen the transfer of electrons from sodium to chlorine. So whenever sodium it loses 1 electron, it forms a cation, and the chlorine, after gaining the electron, it forms a anion. So Na plus and Cl minus are formed due to the transfer of electron between the sodium and chlorine. So these oppositely charged ions, they get attracted towards each other due to electrostatic forces, which leads to the formation of a sodium chloride molecule. Now we'll see the dot structure for this. This is the sodium which has 1 electron in its outermost shell, 281, that is the 1 is the electron in the outermost shell, and chlorine which has 7 electrons in outermost shell. So sodium will transfer its electron to the chlorine. Chlorine is 287. So whenever sodium it loses 1 electron, it forms Na plus And the chlorine, after gaining the electron, it forms Cl minus. So there exists electrostatic force of attraction between the oppositely charged ions and forms the compound called sodium chloride. Okay, so this is the ionic bond. So that means the ionic bond exists between sodium and chlorine due to the transfer of electrons from sodium to chlorine. Now we'll see the next example. Now let us see another example, magnesium chloride, formation of magnesium chloride. Magnesium chloride is formed from its elements magnesium and chlorine. Magnesium Mg and chlorine Cl, and the magnesium chloride is MgCl2. It is formed from the elements magnesium and chlorine. Now we'll write the electronic configuration for magnesium and chlorine. Magnesium atomic number is 12 and its configuration is 2, 8, 2. That means in the last shell it is having 2 electrons. So magnesium can lose its electrons. So whenever magnesium loses electrons, it forms cation. So cation formation, magnesium, which is having 2 electrons in its outermost shell, will lose those 2 electrons to get the octet configuration of neon, that is 2, 8, and forms the cation. The configuration is 2, 8, which is of neon. Chlorine, whose atomic number is 17 and the configuration is 2, 8, 7, which is short of 1 electron, it gains the electron. So gaining of electron leads to the formation of an anion. So chlorine forms an anion. So whenever one chlorine gains 1 electron, it gets the configuration of argon, that is 2, 8, 8, and forms the anion. But magnesium is having the ability to lose 2 electrons, whereas chlorine can gain 1 electron. So 2 such chlorines gain 1 electron each from one magnesium atom, because it can lose or it can donate or it can transfer 2 electrons, whereas chlorine has only short of 1 electron. Two such chlorines gain 1 electron each from magnesium. Now we'll see the transfer of electrons from magnesium to chlorine. Let us see the transfer of electron from magnesium to chlorine. Magnesium atomic number is 12 and configuration is 2, 8, 2. See 12 protons in the nucleus. In the first shell it contains 2 electrons. In the second shell it contains 8 electrons. And in the third shell it contains 2 electrons, which is the outermost shell. See, these are the 2 electrons. So these 2 electrons are to be transferred to chlorine. Chlorine, its atomic number is 17 and it has the configuration 2, 8, 7. Its electronic configuration 2, 8, 7. 17 protons in the nucleus. First shell 2 electrons, and in the second shell it will have 8 electrons, and in the third shell it will have 7 electrons. It is short of 1 electron, but magnesium can donate 2 electrons. So another such chlorine will be there which can take 1 electron. So this is the another chlorine which is having 2 electrons in the first shell, and in the second shell 8 electrons, and in the third shell it has 7 electrons. So these 2 chlorine atoms can gain 1 electron each from magnesium, so that they will form as the magnesium plus 2 and Cl minus. So 2Cl minus and then magnesium plus 2. So this is how the transfer of electron uh, taken place. So we have represented the electron transfer like this. Okay, so magnesium has becomes as Mg plus 2 and chlorine becomes as Cl minus. We'll write the dot structure for this. Formation of magnesium chloride from its ions. So just now we have seen that magnesium transfers 2 electrons and chlorine gains 1 electron. Transfer of 2 electrons from 1 magnesium to 2 chlorines, 1 electron each, results in the formation of the ions Mg plus 2 and 2Cl minus. So these oppositely charged ions, these magnesium plus 2 and 2Cl minus ions, these oppositely charged ions, they get attracted towards each other due to electrostatic forces and forms the compound magnesium chloride. Now we'll write the Lewis dot structure for magnesium chloride. Magnesium, we have seen the atomic number 12 and the configuration 2, 8, 2. That is 2 electrons in its outermost shell. And chlorine, which has the configuration 2, 8, 7, because atomic number is 17. So in the outermost shell, it will contain 7 electrons. It is short of 1 electron. So 2 such chlorines are there, which are having 7 electrons. So magnesium will donate its 2 electrons, 1 each, to chlorine, resulting in the formation of magnesium plus 2 and then 2Cl minus. So these two oppositely charged ions, they are attracted towards each other, resulting in the formation of a magnesium chloride. Okay, so this is the second example. Now we'll see another example. Now we'll discuss another example. Here I'm taking formation of disodium monoxide. It is formed from the elements sodium and oxygen. Its formula is Na2O. Now we'll write the configuration, electronic configuration for sodium and oxygen. Sodium atomic number is 11 and its configuration is 2, 8, 1. That means in the third shell, which is the outermost shell, it can lose 1 electron. Sodium can form a cation. Whenever sodium loses 1 electron from its outermost shell, it gets the octet configuration of neon and has the configuration as 2, 8 and forms a cation. And oxygen, whose atomic number is 8 and whose electronic configuration is 2, 6, it has short of 2 electrons to get the configuration of neon. So it gains the electrons, so it forms an anion. Oxygen, whenever it gains 2 electrons, because it is short of 2 electrons, it gets the 2 electrons from 1 electron each from sodium and get the configuration of neon 2, 8. That means two sodiums, because each sodium has the ability to give or lose one electron only, whereas oxygen requires two electrons. So two sodium atoms, one from each, oxygen will gain and attains the configuration of neon. Now we'll see the transfer of electrons from sodium to oxygen. Now we'll see the transfer of electrons from sodium to oxygen. Sodium atomic number 11, electronic configuration 2, 8, 1. So 11 protons in the nucleus. In the first shell 2 electrons, in the second shell 8 electrons, and in the third shell it has 1 electron. So sodium can lose only 1 electron. So this is the third shell, which is the outermost shell, which sodium can donate the electron, whereas oxygen requires 2 electrons. So another such sodium will be there. This is another sodium with 11 protons. First shell 2 electrons, second shell it is having 8 electrons around this C, and in the third shell it has 1 electron. Yes, this is the single electron. So sodium in its outermost shell, they are having 1 electron each. So these 2 electrons are transferred to oxygen, because oxygen requires 2 electrons. Its electronic configuration is 2, 6. See, first shell it has 2 electrons, and in the second shell it contains 6 electrons. See, these are the 6 electrons. So these 2 electrons from sodium, this electron and this electron, they are transferred to the oxygen so that it can attain the octet configuration of neon. Okay, so now see, the transfer of electron takes place. Right. So here oxygen has got 8 electrons now, and here sodium also has got the octet configuration of neon by losing the electron, and the oxygen by gaining the 2 electrons, it also got the octet configuration. Now we'll write the Lewis dot structure for this. Formation of disodium monoxide from its ions. Just now we have seen that 1 electron each from 2 sodiums are transferred to oxygen because it is short of 2 electrons, which results in the formation of the cation as well as the anions. Transfer of electrons from sodium forms as 2Na plus, because 2 sodiums are donating 1 electron each and oxygen is gaining 2 electrons, so O2 minus. So due to electrostatic force of attraction between these oppositely charged ions, it forms a chemical compound called disodium monoxide. Now we'll write the dot structure for disodium monoxide. Sodium atomic number 11, electronic configuration 2, 8, 1. So it contains 1 electron, it's the outermost shell. 2 such sodiums are there, which has 1 electron in the outermost shell. And oxygen, which is short of 2 electrons, will have 6 electrons in their outermost shell. And now these 2 electrons are transferred to oxygen, 1 from each sodium, so that sodium, by losing the electron, 2 sodiums are there, so it forms 2Na plus, and oxygen is taking 2 electrons, so it forms O2 minus, and this oppositely charged ions results in the formation of disodium monoxide. Okay, Now we'll see another example. Formation of aluminum chloride, AlCl3. It is formed from the elements aluminum and chlorine. Now we'll write the electronic configurations and let us see how many electrons can be transferred and how many electrons are gained. Aluminium, its atomic number is 13. Its electronic configuration is 2, 8, 3. That means it can lose 3 electrons to get the configuration of neon. So aluminium forms cation. Aluminium, when it loses 3 electrons, to get the octet configuration of neon, it forms cation and attains the configuration as 2, 8. And chlorine, whose atomic number is 17 and its electronic configuration is 2, 8, 7. And we have seen that just now in the previous, that is sodium chloride, it is short of 1 electron. So here also 7 is there, so it is short of 1 electron. But aluminium can give 3 electrons, whereas chlorine can gain 1 electron. So when chlorine attains 1 electron, it gets the configuration of argon, that is 2, 8, 8, and forms anion. So 3 such chlorine atoms gain 1 electron each because aluminium has the ability to lose 3 electrons. So these 3 electrons are donated to 3 such chlorine atoms which are short of 1 electron. So here aluminium forms cation and chlorine forms the anion. Okay. Now we'll see the transfer of electrons. Now we'll see the transfer of electrons from aluminium to chlorine. Aluminium atomic number is 13. Its configuration is 2, 8, 3. See, these are the 13 protons. And in the first shell, it has 2 electrons. In the second shell, it has 8 electrons. And in the third shell, it will contain 3 electrons. These are the 3 electrons. These 3 electrons are transferred 1 electron each to chlorine. Chlorine, its atomic number is 17 and its configuration will be electronic configuration is 2, 8, 7. So these are the 17 protons. In the first shell it will contain 2 electrons. In the second shell it will contain 8 electrons. And in the third shell it will contain 7 electrons. So it requires 1 electron. These are the 7 electrons. It requires 1 electron. So it gains the electron from aluminium. Yes, see, it has got 1 electron, so that its configuration has become as 2, 8, 8. So such another 2 chlorines will be present which has the same 2, 8, 7. See, this is the second chlorine. It has 2 electrons in the first shell. In the second shell, it has 8 electrons. And in the third shell, it will have 7 electrons. So again, it requires 1 electron. So it gains 1 electron from aluminium. And again, it will get the octet configuration as 2, 8, 8. So this has got 1 electron. Okay. So another chlorine whose configuration will be 2, 8, 7, and the aluminium which is having another electron it will donate its last electron to another chlorine. This is a chlorine, 2 electrons in the first shell and 8 electrons in the second shell, and 7 electrons will be present in the third shell. See, these are the 7 electrons. So it requires 1 electron. So aluminum, it will donate its 1 electron to the chlorine. Okay. So it gains 1 electron. So again the chlorine has got 288. So 3 electrons, they are transferred 1 electron each to 3 chlorines. Here 1 electron, here 1 electron, and for this 1 electron. So transfer of 3 electrons from aluminium to 3 chlorines takes place. Now we'll write the dot structure. Formation of aluminium chloride from its ions. See, we have seen that aluminium donates 3 electrons, 1 electron each to chlorine. Transfer of 3 electrons from 1 aluminium to 3 chlorines, 1 electron each to 1 chlorine, will form the ions as Al plus 3 and 3Cl minus. So again, due to electrostatic force of attraction, they come closer and form the ionic bond. And the molecule is the aluminium chloride. So here 3 electrons are transferred, 1 electron each to 3 chlorine, and the compound formed will be aluminium chloride, that is AlCl3. Now we'll write the dot structure for this. See how the electron transfer takes place. Aluminium 2,8,3. 3 such aluminiums will be there. Sorry, one aluminium will be there which can donate 3 electrons through to 3 chlorines. These are the 3 electrons present in the outermost shell. Now we'll have 3 chlorines which are short of 1 electron each. This is 1 chlorine with 7 electrons, and this is another chlorine, 7 electrons with it, and the third chlorine which is also short of 1 electron. So now aluminum, it will donate 3 electrons, 1 each to chlorine, so that aluminium, it forms Al plus 3, and chlorine, it forms 3Cl. 3 chlorines are each one taking 1 electron, so 3Cl minus, and which results in the formation of a compound called AlCl3. Okay, this is about the ionic compounds with some examples. So I hope you have understood. Thank you so much.